Hello, my dear students. How are you all? I'm fine. I'm Khandakar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. During this pandemic situation, welcome you all to our online chemistry class. Today, we discuss about some creative question from chemistry first paper, chapter 4, chemical change. Dear students, this is our first stem. Here given first reaction, carbon disulfide reacts with oxygen and it produces carbon dioxide and sulfur dioxide, and del H value of this reaction is minus 1109.2 kilojoule per mole. And in our second reaction, carbon plus oxygen reacts and it produces carbon dioxide. Del H value of this reaction is minus 394 kilojoule per mole. And in our third reaction, here given sulfur plus oxygen reacts and it produces sulfur dioxide. The del H value of this reaction is minus 297 kilojoule per mole. And our first question is, how much liter of oxygen at STP is needed to produce 1200 kilojoule heat by the reaction number 2 in the stem. So, according to the stem, question answer C, according to the stem, reaction number 2 is carbon plus oxygen, it produces carbon dioxide, and del H of this reaction is minus 394 kilojoule per mole. That means from the reaction it is seen that to produce 394 kilojoule heat, 1 mole oxygen is required. That means to produce 394 kilojoule heat, 1 mole oxygen required. 1 mole oxygen required. Again at STP 1 mole oxygen equal to 22.4 liter. So, to produce 394 kilojoule heat, oxygen required 22.4 liter. And according to our stem, question number C, to produce 1200 kilojoule heat, oxygen required 22.4 into 1200 divided by 394 liter, and that the answer is 68.223 liter. So, from question number C, we get the answer. To produce 1200 kilojoule heat by reaction number 2, 68.223 liter oxygen is required. Students, our second question is analyze whether the reaction of formation of carbon disulfide is exothermic or endothermic according to the STAM. So, according to the STAM, due to combustion of carbon disulfide, reactions are answer D. According to the STAM, reactions are carbon disulfide, first one CS2 plus 3O2, CO2 plus 2 SO2. Here 2 SO2 and the del H, this is the combustion reaction of carbon disulfide. So, here we write del HC for this reaction, that means combustion enthalpy of carbon disulfide, del HCCS2 equal to minus 1109.2 kilojoule per mole. And in our second reaction, carbon plus oxygen reacts and it produces carbon dioxide, and del H value, del H, that means this is the combustion reaction of carbon and formation reaction of carbon dioxide. So, we can write del HC, that means combustion enthalpy of carbon equal to del HF CO2, that means this is the formation reaction of carbon dioxide, that is why we write formation enthalpy of carbon dioxide equal to minus 394 kilojoule per mole. And in third reaction, sulfur plus oxygen reacts and it produces sulfur dioxide, and del H, you can also write here del HCS, that means this reaction is the combustion reaction of sulfur and it is also formation reaction of sulfur dioxide. So, here we can write del HCS, that means combustion enthalpy of sulfur equal to formation enthalpy of sulfur dioxide, that is minus 297 kilojoule per mole. Now, according to our first reaction, heat of combustion of equation or reaction number 1, we get del H C CS2, that means combustion enthalpy of carbon disulfide equal to formation enthalpy of product minus formation enthalpy of reactant, that means del HF CO2 plus 2 del HF SO2 minus del HF CS2 plus 3 del HF O2, and we need the value of formation enthalpy of carbon disulfide. Formation enthalpy of carbon disulfide. So, if we cite change or del HF CS2 equal to del HF CO2 plus 2 del HF SO2 minus 3 del HF O2 minus del HF del HC CS2 or del HF CS2 equal to the value of del HF minus 394 plus 2 into minus 297 minus 3 into 0, because formation enthalpy of oxygen equal to 0 minus the value of combustion enthalpy of carbon disulfide here given minus 1109.2, and we get the value 121.2. Here this is positive. So, here the value of del HF CS2 is positive. So, the reaction is endothermic. My dear students, here stamp 2, here given P and Q are two saturated hydrocarbon containing one carbon and two carbon atoms respectively. Both of the compound used as a fuel, a gas C and a liquid D, are produced after combustion of both compound P and Q. The heat of formation of P, Q, C and D are minus 74.89, minus 84.9, minus 393.3 and minus 220.20 kilojoule respectively. And our first question is, how much heat is produced in kilojoule if 25 gram of P is combusted from the stamp? And if we see the stamp, P and Q, here P and Q are two saturated hydrocarbon. So P represents methane and Q represents ethane, C2H6. Okay, and here given that gas C and a liquid D are produced after combustion of both compound. So C represents carbon dioxide and D represents water. And according to the stem, formation enthalpy del HF CH4 equal to minus 74.89 del HF C2H6 equal to minus 84.9. Here unit is kilojoule per mole, kilojoule per mole, and del HF CO2 equal to minus 393.3 kilojoule per mole, and del HF H2O, this is liquid, minus 220.20 kilojoule per mole. So our question was how much heat is produced in kilojoule if 25 gram of P, that means CH4, is combusted from the stem. Now answer of the question C. Corresponding combustion reaction of methane is CH4 plus O2, here one carbon present, so we get 1 mole carbon dioxide and 4 hydrogen, so 2H2O, and number of oxygen here 2 and 2 plus 2 equal to 4, so here we use 2 oxygen. And combustion enthalpy del HC CH4 equal to the formation enthalpy of product minus formation enthalpy of reactant. So del HF CO2 plus 2 del HF H2O minus del HF CH4 plus 2 into del HF O2. Here the value of carbon dioxide is minus 393.3 plus 2 into minus 220.20, and formation enthalpy of methane minus 74.89 minus formation enthalpy of oxygen equal to 0, and we get the value minus 758 minus 758.81 kilojoule per mole. Again, we know that molecular mass of methane equal to 16. So 16 gram methane produces, so 16 gram CH4 produces 758.81 kilojoule heat, and 25 gram methane produces 758.81 into 25 divided by 16, and the answer is 1185.64 kilojoule. So according to our calculation, we can say that from 25 gram methane it produces 1185.64 kilojoule heat. Dear students, our next question is, analyze mathematically which one is better fuel between P and Q in the stem. So answer D. From answer part C, we see that combustion enthalpy from C, we see that combustion enthalpy of methane del HF CH4 equal to minus 758.81 kilojoule. So the amount of heat per gram, so the amount of heat per gram methane del HF CH4 equal to minus 758.81 divided by 16 kilojoule equal to minus 47.43 kilojoule per gram. Now the combustion reaction of ethane, now combustion reaction of ethane C2H6 plus O2 equal to 2CO2 plus 3 H2O, and here we have to write oxygen 2 into 2, 4 oxygen plus 3 oxygen, 7 oxygen. So we multiply here 7 by 2, and combustion enthalpy of C2H6 equal to 2 del HF CO2 plus 3 del HF H2O minus del HF C2H6 plus 7 by 2 del HF O2 equal to 2 into minus 393.3 plus 3 into minus 2 to 0.20, and formation enthalpy of ethane, that is minus 84.9 plus 7 by 2, formation enthalpy of oxygen equal to 0, and we get the value as 1362.3 kilojoule per mole, and minus 1362.3 divided by 30, because the molecular mass of ethane is 30, then the unit is kilojoule per gram, and the value is minus 45.41 kilojoule per gram. Here we see that the combustion enthalpy of methane, combustion enthalpy of methane per gram is higher than that of ethane. So methane is a better fuel than ethane.